Good morning. Today we are discussing about a phosphorus compound called phosphine and its chemical formula is pH3. First, its preparation. How can we prepare? First method, by reaction of calcium phosphate with water or dilute HCl. Okay, calcium phosphate with water or dilute HCl. How can we obtain? Calcium phosphate is Ca3P2 plus water gives calcium hydroxide and phosphine. Now, calcium phosphate with HCl gives CaCl2 plus phosphine. First method of preparation. Okay. Now, second method is laboratory preparation. In this method, by heating white phosphorus with concentrated sodium hydroxide in an inert atmosphere, of carbon dioxide, the product obtained is phosphine. Okay. P4, that is white phosphorus with concentrated NaOH plus 3H2O. Reaction is as follows. It gives pH3, that is phosphine, and the product obtained is 3NaH2PO2. This is sodium hypophosphite is obtained. Okay. Sodium hypophosphite and phosphine is obtained. Now, when pure, this phosphine is non-inflammable but becomes inflammable due to the presence of P2H4 or P4 vapors. In presence of these impurities, phosphine become inflammable. So, we have to remove this. To purify it from impurities, first we have to absorb it in HI, that is hydrogen iodide. Okay, it is absorbed in HI and form phosphonium iodide. Phosphonium iodide is obtained, which is PH4I. This phosphonium iodide, on treating with potassium hydroxide, it gives phosphine, that is PH4I, phosphonium iodide with potassium hydroxide gives potassium iodide, H2O, and pure phosphine is obtained. Okay, these are the different preparation. Okay, next we are discussing some important properties. Okay, properties. Phosphine is a colorless gas with rotten fish smell and is highly poisonous. Okay. It's a colorless gas, rotten fish smell, and it is highly poisonous. It's a poisonous gas. Okay. Next, slightly soluble in water. Solution of pH3 in water, it decomposes in presence of sunlight and giving red phosphorus and hydrogen. So, it is slightly soluble in water. Okay. And its solution of pH3, that is phosphine in water decomposes in presence of sunlight. Okay. In presence of sunlight, it decomposes and forms red phosphorus and hydrogen. Okay. Now, third point, when absorbed in copper sulfate or HgCl2, mercury chloride, phosphides are obtained. That is with copper sulfate. With copper sulfate, phosphine gives Cu3P2, that is copper cupric phosphide is obtained plus 3H2SO4. Then with mercury chloride, what happens? Phosphine gives Hg, mercuric phosphate is obtained by mercuric phosphide and 6HCl. Okay, these are the reaction with copper sulfate and mercury chloride. Okay, now next property, phosphine is weakly basic in nature. It's weakly basic, like ammonia. Ammonia is also basic. Okay, so it's weakly basic like ammonia. It gives phosphonium compounds with acids. It gives phosphonium compounds with acids. That is phosphine with HBr. With HBr, it gives PH4PR. So it is basic in nature. Next, different uses of phosphine. Uses. First important use, it is used in home signals. Home signals. What is home signals? Home signals. Home signals because it is spontaneous, due to its spontaneous combustion of this phosphine, it can be used in home signals. Its property is spontaneous combustion. It's highly inflammable. Okay, so spontaneous combustion of phosphine, this property helps in home signals. So here containers containing calcium carbide and Ca3P2, calcium phosphide. Okay, so a mixture of calcium carbide and calcium phosphate are pierced in a container. Okay, are pierced in containers and these are thrown in the sea. So what happens? Where gases evolved and burn, and it serves as a signal for different ships to give signals to the nearby ships. Okay, so the containers containing calcium carbide and calcium phosphate are pierced with and thrown in sea. Where gases evolve, they burn and serve as a signal. So it is used in home signals. And another use, it is used in smoke screens. In smoke screens. These are the important uses of phosphines. Okay.